If you are developing or maintaining open edge applications, speak with us. With over 15 years of experiences, Consulting Work offers the services which help companies to modernize open edge systems to increase customer satisfaction, enhance flexibility, lower risk, and reduce operational costs. The comprehensive consulting services include assessment, analysis, prototyping, training, coaching, mentoring, and implementation. We are supporting developers all over Europe and globally. The Smart Component Library is the developer's framework for open edge, on the desktop, the web and mobile. The framework was designed to meet the demands of the classic ABL developer as well as object-oriented purists. The framework provides the architecture required to build modern, future-proof applications today and facilitates integration with existing open edge applications and the modernization of those. Data and application logic is equally consumed by our own front-end technology based on .NET, Angular or native script or partner front-ends and service consumers based on popular standards such as RESTful. The framework is successfully used by developers in teams of literally any size, from single developers to multinational distributed developer teams. Latest features demonstrated here are the conference include dynamic tables, status-based workflows, user authentication based on Office 365, Google or Facebook. And now, please welcome our Dr. Webb.
Hello everyone, my name is Radu Nicoara. I'm a consultant and developer with Consulting Work. I have several years of experience in Angular, NativeScript and Node.js. I'm the developer of the Smart Component Library for Angular and NativeScript frontends, and I also support customers and offer consultation for web and mobile architecture and provide training and mentoring services. Today we'll be talking about unit testing web applications. Now, the first question is, does that really matter, unit testing web applications? I mean, you might be used to just clicking refresh in your web browser, clicking the buttons, sorting your grids, that kind of thing, maybe resizing the window and say, well, this looks like it works, it's nice, it's shiny. But how many hours on end have you spent, performing regression tests, making sure that absolutely all your screens work just by manually clicking all of your buttons? And also, how many times have you resized the window, just the few pixels at a time, just to make sure that it all still looks nice on different resolutions and all of that? And yeah, also trying it in different browsers, might look nice on Chrome, might not look nice on Safari and so forth, or maybe some obscure mobile browser that nobody's heard of. All of those things need to be tested, and you've probably wasted a lot of hours so far with your web applications by testing in all of these environments. Now, the other clear benefit to unit testing your web applications is that it frees up QA resources to focus on new functionality rather than verifying that existing functionality has not broken, even if that means testing that button is still the same color or some text still displays in exactly the same format that you're expecting it to on a certain device or resolution. Now, how do we get to actually being able to unit test automatically and verifying that everything looks like it should? Well, the first thing we need to do is to produce testable code, obviously. So what that means is we need to be decoupling the UI from the other code. And also we need to adhere to the separation of concerns principle. Now, you may be asking yourself, how does that work, separation of concerns in a web project? Well, I can understand that question. Normally in a web application, especially if you're using something like jQuery, you're pretty used to your HTML, CSS, and JavaScript code all being tightly coupled. But with Angular, that becomes quite trivial and quite feels natural to do. So the way Angular architecture is, it's centered around component composition, and applications are organized in modules. Now, Angular modules are not the same as ES6 modules. Angular modules are a logical way of grouping your components and various parts of your application, such as services and other business logic that you may want to be executing, in such a way that they become reusable. Even across multiple applications, you could even publish a library with some directives and UI components or just services and so forth. Also, rendering is decoupled from the DOM, and that's a very important thing that will help you decouple your UI from your logic. So how does this benefit us? Well, it makes it easy, like I said, to separate UI from other code, and it makes it very easy to implement separation of concerns. Now, Angular offers a variety of concepts such as services, pipes, and root guards, and we're gonna, before going further into unit testing, I'd like to quickly go through these concepts, because we'll be using them in the examples of unit tests later on. So, services. Services are primarily used to handle CRUD operations, but that's not the only thing you could use them for. You could be using them for anything non-UI related. The way they work is you add a injectable annotation on a class, and what this does is it tells Angular that that class needs to be able to be injected into various UI components via the Angular dependency injection system. Now, this is useful because, because you can centralize all of your, let's say you have users endpoint, REST endpoint, and you would like to have all of your logic for performing CRUD operations in one place and not start performing HTTP requests from your UI code, which is very useful for unit testing. You would just have a data service class. As you can see from the constructor, an HTTP client service is being injected here. And we have a method called getData, which essentially just performs a get REST call on your endpoint and returns the expected result. Now here we have an example of a component. You can tell by the @component annotation. There's also a selector, appData component. We can use this in our HTML markup if we want to render the component at a certain place. And you can see from the template, we're simply displaying the data that's being returned from the service class and passing it through a JSON pipe. I'll get to that in a minute. Then we see in this components constructor that we are injecting the data service class, data service class, in the same way we were injecting the HTTP client in the data service. ng on init, that is what we call a Angular lifecycle hook. There are a number of these. There's ng on init, ng after view init, ng on changes, and so forth. These all get called at various stages of an Angular component's lifecycle, and they're very useful. So here what we're saying is when this component initializes, before it has been actually rendered on screen, we are calling the getData method on our data service, and then we're saving the result locally. Now, you can see the data variable there. That is actually what's being displayed in the template. The JSON pipe, what that does, it just calls JSON stringify on whatever's being passed to it and renders the result on screen. But we can further simplify this by not making a subscription to the getData observable and saving the result of that subscription locally. We could save the observable itself and then our UI template pass it through the async pipe and then further pass it through the JSON pipe. Now the async pipe will do the subscription to the observable for us, and then once the data has been streamed, it's going to be passed to the JSON pipe. Finally, we're going to get the stringified JSON of our data on screen. Now moving on to route guards. These are primarily used for determining whether a user can navigate to a route, but they can be used for pretty much anything, Angular route related, that is. It can also be used for such purposes as determining if a page can be unloaded, and they make testing functionality such as authorization very easy. Here is an example of a route guard. This one is called authentication guard, and it implements the can activate interface. Now, what this means is that it's going to have a can activate method, which Angular will call automatically before navigating the user to the requested route. You can see in the instructor we're injecting a user service, and the can activate method simply returns true or false based on whether the current user is authenticated. So what this will essentially do is prevent a user from navigating to a certain page unless they are authenticated. It's easy as that, and this class is now reusable across all of our Angular routes, which makes it very, very easy to maintain. This is a sample route configuration that uses the previously discussed route guard. As you can see, we just have a path, account settings. Obviously, a user should be authenticated to be able to navigate to their account settings. We tell it the component that's going to be rendered for the user when they navigate to that route. And finally, we tell it that it needs to go through the auth guard in order to be activated. You probably notice that the can activate setting is actually an array, which means we can add multiple sequential route guards there, and then Angular will take the navigation through all of those guards, and if one of them on the chain returns false, then the user will not be allowed navigation to that path. Now, let's move on to the actual unit testing part. So Angular's test runner of choice is Karma. Karma is a JavaScript test runner. It's not only used by Angular, it's more or less the de facto test runner for any JavaScript project. It's very easy to configure, and the nice thing is it supports multiple reporters. So you could have your test results reported as JUnit, XUnit, HTML, OCUP, whatever you prefer, and also any combination of those. And there's also a very rich plugin ecosystem, so you can just plug various things into the Karma test runner, and we're going to see how we can make use of that for some pretty neat functionality. Now moving on to the actual testing framework. Angular's testing framework of choice is Jasmine. So what Jasmine provides are assertions and spies. Those are the most important things out of the box, but also a variety of other useful things. It's used by default in all projects that are scaffolded using the Angular CLI. There are other testing frameworks out there, such as Chai or others. But for the purposes of this presentation, we'll be covering Jasmine and how it works with Karma and Angular. Now, here we have a sample Karma configuration. As we can see here, we have the frameworks setting, which is telling it to use Jasmine as a testing framework, and also some built-in testing functionality provided by the Angular dev kit. And also a list of plugins. This one is quite important for our conversation here. So as you can see, we're requiring Karma Jasmine, Karma Chrome Launcher, Karma Jasmine HTML Reporter, Testable Reporter for code coverage, and some built-in Angular Dev Kit plugins. Now, the Karma Chrome Launcher plugin makes it so Karma is able to automatically launch a browser to run our tests in. The HTML reporter will generate a very nice looking HTML test result report for us. And we also have the coverage Testable reporter so that we get a nicely formatted code coverage report. And you can see further down that we also provide a separate configuration for the Testable reporter. We tell it which formats to use, fix the Webpack source paths, and so forth. There's also some settings such as the log level, whether it should watch for code changes and then rerun the tests, and so forth. So how do we use all of this? Well, we use it through the magic of the Angular productivity tool, which is the ng CLI tool. So the project is automatically configured to use the appropriate tools if you have used the Angular CLI to scaffold it. Every time you generate a component using the CLI tool, it will generate a spec file for it as well, which is essentially a TypeScript file that has the same name as your component's TypeScript file, but with the added suffix of spec. And then to run all of your tests, which essentially means run all tests found in all spec files, you just run ng test, which, as you can imagine, is also very easy to integrate in any pipeline, in CI pipeline. The naming convention is, as I've mentioned, SRC. So all of your Angular code is going to go under SRC, and then just use anything that matches .spec.ts. Some basic testing functions are before each, which is a callback that will be run before every test. This is essentially your setup method. So here you would be initializing your component with whatever inputs you want, initialize certain services, and so forth, anything you need essentially for your test to be able to run. Describe, it's used to describe a suite of tests, and under describe we have a multitude of its, which essentially an it declares a single test, and yeah, the execution for it. And very, very widely used function in Angular unit testing is the expect, which is essentially an assertion. So you expect something to be false, you expect it to be truthy, you expect it to equal something, or there's even such a statement as expect something to be okay, which means it's truthy, it hasn't thrown an error, or anything along those lines. Here is an example of these functions in action. So here we're using describe to declare a test suite for our app component. Before each, we are configuring a testing Angular module. Very importantly, we're importing in this module the router testing module instead of the actual router module, because we do not want any sort of automatic router navigation to actually change the page that the test is running on. We are declaring our app component, and finally we are calling compile components. Then, as mentioned earlier, we have an it statement, an it call, sorry, and we just tell it it should create the app, and this is how it's going to appear in our test results report. We get the component fixture, and then we get the actual component instance, and we expect the app component instance to be truthy. So not null, not undefined, we expect there to be an app component instance. And that's one unit test example. Now, I've mentioned fixtures previously. Let's go a bit into what those are. They are wrappers over the regular Angular components that Angular creates for the testing environment. They provide programmatic access to the component instance as well as the component's template. And it allows, fixtures allow you to simulate various inputs for your component, which you would not normally be able to do for security reasons in your actual development environment. And furthermore, it allows simulating interactions such as clicks, key downs, and so forth, which some browsers will prevent you to do in your actual, when actually running your applications, to prevent things like click hijacking and so forth. But in the testing environment, you are able to simulate any such user interactions, which can be extremely useful. Let's also briefly go over the concept of spies. So spies in Angular testing are very useful for testing the behavior of components because they can stub any function. It allows tracking of calls and arguments. So for example, an assertion could be essentially, I expect this function, this method of this component to have been called when the user has clicked a button. And furthermore, I expect this method to have been called with this argument, with these arguments, and this exact number of times. Now, as you can see, this can be very useful for testing, event handling such as button clicks, mouse moves, window resizes, and so forth. Here is an example of such a spy. Essentially, we say it should call the onClick handler when clicking a button. So essentially, our component has a method called onClick handler, and we want that method to be called when the user has clicked a button. So what we do here is we get the component fixture, as previously mentioned, and then we call spy on the component instance and give it the method name that we're spying on. We call detect changes on the fixture because the Angular change detection mechanism does not run automatically in the testing environment. We have to call that manually or explicitly tell Angular that we want it to run automatically. I do not recommend running the change detection mechanism automatically in a testing environment because there are some circumstances where your components might never actually reach a stable state. So for example, if you're listening on window resizes or mouse moves and so forth, you might not reach a stable state and then your tests will not run and eventually throw a timeout error. So we then get the native element, which is the actual HTML element, and we do an old-fashioned JavaScript query selector for a button that has the myButton ID. And then we simply call click on the button, which normally in some browsers would not work because things like clicks, most modern browsers actually require a real user interaction for that, for good reason. And then finally, we call expect. So essentially, we assert that the onClick handler has been called at least once. You can see the syntax here is quite neat and suggestive. So essentially, we're saying expect component instance.onClick handler to have been called. What code is easier to read than that, really? Now moving on to mock data. When unit testing Angular web applications, often you will want to mock the data that would otherwise be retrieved through HTTP request calls. Why? Well, because your unit tests should not be dependent on a working backend. I cannot tell you how frustrating it is to have a CI pipeline fail because one or more unit tests have crashed due to an offline backend or an offline internet connection. Thus, we can make use of the rich features that the Angular testing environments provide and mock our data and our services instead of relying on actual working backends. The downside to this is that you have to make sure that the data you are mocking actually matches, at least in terms of structure, the data that would be returned by an actual backend. So you have to be very careful when there are changes in the backend that your web app works with, that you update your unit tests with newly mocked data. Otherwise, you will see your unit test passing, but in a real environment, they might your app might actually fail, might actually crash because it's not receiving the data it's expecting to receive anymore because of a backend change. So really, really be careful with that. But otherwise, there are various advantages like more predictable tests of your Angular services. Obviously, you control what data is returned, and you're not depending on a running backend. So here's how we would use mock data. As you can see, I have here two examples of two Angular classes. So we have here a real service class, which would be your Angular service that makes the actual HTTP call to the backend to get data. And on the right, we have a fake service class. The constructor, very importantly, has the same signature as the real service. And there's also an identical, a get data method that has an identical signature as the real service. But the key difference here is that we are using a static set of values and are returning an observable created on the fly based on those values in our fake service instead of actually making the HTTP call. Now, in the real world, when your app actually runs in a browser, it's going to make obviously an HTTP call. But we're going to see in a minute how in our testing environment we can trick the Angular environment to think it's using the real service when in fact it's using the fake service. So here we're again configuring the testing module. The testing module is configured more or less in the same way as you would configure an actual app module or a feature module and so forth. You have your imports, your component and directive declarations, providers and so forth. Now here we're going to be focusing on the provider setting. So here, as you can see, we're telling it for the real service class provider to use class fake service. Now what this does is essentially make the Angular environment so that if in your component you are injecting the real service class into your constructor via the dependency injection system, you will actually be receiving an instance of the fake service. But your components would be none the wiser. They would essentially treat it as a real service. I'm going to call the getData method on it and use the result, which for the fake service is an actual static set of data, not something retrieved from the backend. Now, moving forward, reporters. Reporters are used for displaying and storing test results. Now, we can use multiple reporters, and the most popular reporters are obviously, well, Progress, which is used when you're running unit tests in your terminal. And we have the coverage reporters that can output to HTML and LCOV. Very useful if you're using things like Jenkins or Circle CI and so forth. This is how you would use code, how you would display code coverage when you're running your tests in your own terminal. You just add the code coverage flag to the ng test CLI tool, and you get something like this outputted. So it tells you the percentage of branches, statements, functions, and so forth that have been covered. You can also get a static HTML file, which looks like this. As you can see, it is very, very nicely formatted. It's navigable with clicks and keyboard shortcuts and so forth. And if you use something like Jenkins, you can make it so it displays this HTML file in a separate page for all of your pipeline builds, which is very nice, and I find that very useful. Now let's move on to something that is not really provided out of the box, but is not very difficult to implement, and I find very useful when doing unit tests, especially if you're running your test through a pipeline. Taking screenshots. So I find it extremely useful to run some test suites in a pipeline automatically, and then later I'm able to go to my Jenkins instance, for example, check the result of that build, and then go to the artifacts and find a full set of screenshots with a number of screenshots available after running every unit test. So I can actually see, apart from the obvious test results, I can inspect what my components look like after each test has run its course. That is very useful for somebody working in QA, for example. You just go to that pipeline and look through all the screenshots. If you notice something that your unit test might have missed, a button that's not where it should be or something like that, you know, having the screenshots, it's very useful. So manual visual inspection without having to actually have someone run your web application in a browser and start clicking and navigating through all the screens and so forth. Your unit test can do all of that automatically, and then at a later time somebody can just come and visually inspect all the screenshots, which is very useful. There's actually also a way, but I'm not going to go into that today. Feel free to email me if you'd like to know more about that. There is also a way to unit test the screenshots in the sense of you could be comparing them to a set of other screenshots that you know look okay, and then you could be saying how much of a difference is there between these two screenshots. Oh, this is too big of a difference, my unit test will fail now. That is a very useful thing to have, in my opinion. This provides a clear way of inspecting that your components look like they're supposed to in different environments that your unit test will be running on, and easy way of inspecting the impact that the input changes have on the overall aspect of your components, because DOM assertion can be very, very fragile. So for taking screenshots automatically, we will be using Nightmare. Not exactly sure why the authors chose to name this browser Nightmare, because there's nothing nightmarish about it. It is a high-level browser it's a high-level browser automation library. It provides simple methods that mimic user actions, And also it uses Electron, which can be a little resource intensive, but well, realistically, if you're going to be taking screenshots automatically, you're going to be doing that in a pipeline running somewhere on a build server. You're going to have the necessary resource. It's not that resource intensive. And yeah, it provides the ability to programmatically take screenshots from a headless browser. That's a very important part if you're going to run your unit tests through pipelines. You do not need an actual browser window to be open in UI. You could be running these in a headless Linux environment, for example. It will still work and will still render screenshots as if your test had run and rendered in an actual browser like Chrome or Edge or any such example. Yeah. And also, very importantly, it provides a nice Karma plugin for easy integration. So yeah, you just plug it into your Karma environment, give it some settings, and you're good to go. More on that in a second. So here is a sample nightmare configuration with Karma. So essentially, we're telling Karma to use the nightmare browser, and we're also loading the Karma Nightmare plugin, which needs to be installed via npm install. We give the Nightmare browser some options. We give it a width, we give it a height, and we say show false, which essentially means run headlessly. Don't open a window. Now, to actually take a screenshot, all you would need to do is, you'd say it should render a title, like in this example. You get your fixture, you detect changes, you get the native element, and then you just call the screenshot function and give it a relative path to your test suite. And that's it. You've saved the PNG file of a web app screen that's running in a headless browser. And then you can carry on with your assertions and so forth after having taken a screenshot that will be available for manual inspection at a later time. That is very, very, very useful. Cannot stress how useful I found that. And now I would like to quickly show you how to perform a unit test and take a screenshot while you're at it, an automatic one, and also how to mock a service for your testing environment. So what we see here is a stock Angular project generated with the ng CLI tool. The first thing we're going to want to do is install the Nightmare browser and the Nightmare Karma plugin that we discussed earlier. So for that, I'm going to use npm i-d, which tells npm to install this only as a development dependency, so not a production one. The package name is Nightmare Karma. Oh, actually, sorry. The package name is Karma Nightmare. And I'm also going to go ahead and install the Karma TypeScript typings so that we get code suggestions and so forth. This looks like this. Okay, I'm going to wait for it to install. Should only take a couple of seconds. Okay. The next step is to configure the Karma test runner to actually use the newly installed Nightmare plugin. So for this, we're going to add the Karma Nightmare plugin to the plugins list. So we're going to be requiring it like so. Next step is to give Nightmare some configuration options like resolution and whether it should be displayed on screen or not. For this, we simply add a Nightmare options setting here. We tell it, okay, your width should be 800 pixels. Your height should be 600 pixels. And we don't want it to be displayed in the GUI. So show should be set to false. Okay, that's it for configuring Karma. Now, I've already added here a fake service and a real service. So the real service, it's not performing an HTTP request like we saw earlier, but it is returning an observable of an array of strings. Now the strings are, this is real data. The fake service, on the other hand, we see has also has a getData method that returns an observable of strings also. And here the strings are, this is mocked data. Now we're going to go in our app component. This has been scaffolded by the CLI tool, so we're going to just go ahead and delete this. And via the constructor, we're going to inject an instance of the real service. And let's also import it. So as you can see, we're injecting the real service class imported from the real service TypeScript file. Now, let's perform a task on initialization. If you recall, we discussed Angular component lifecycle hooks a bit earlier. So I'm going to implement the onInit interface. And what that means is that I will now have a ng-onInit method, which will automatically get called on initialization. I'm going to declare here the data object, which is of type observable string array. And upon initialization, I'm going to say real service get data and assign the observable to the class's data variable. Okay. Next step would be to display this in the UI. This is the standard app component HTML that gets scaffolded when you generate a project using the Angular CLI tool. So I'm just going to go ahead and delete all of this. And I'm going to say h1 Angular testing, and then I'm going to display the data. I'm going to pass it, since it's an observable, through the async pipe. And further, I'm going to pass it through the JSON pipe so we can stringify the resulting JSON and display it on screen. Okay, now let's just quickly run this. So you see that we get the this is real data string array on screen. Oops. Already in use. Okay, no problem. So the Angular compiler is now building our web application. Okay, now let's just open a browser. this is real data. Okay, now let's go to our app component spec file. This is the standard spec file that has been scaffolded by the Angular CLI tool. What we're going to do here, see here where we are configuring the test module, we're going to add a provider setting and say provide real service use class fake service, and let's just import that. Fake service. Okay. Now let's delete this and simply take a screenshot. Oh, I need to import screenshot. Give it a relative path. Let's delete the other generated tests. Save our file and run ng test. So it started a browser for us. This is the Google Chrome browser. Spec has no expectations. And should be seeing a screenshot.png file around here. Okay, so this is actually a good point to demonstrate. So we see here, we just saw that there was nothing in the browser, and we got a warning that the test case does not expect anything. That is because we actually need to create a component fixture. So fixture, okay. And before each test, we need to create a component fixture. And then fixture should be detecting the changes. And now since we actually really do not have any expectations, we should be saying expect nothing. And as we can see, we now have on screen, this is mocked data, even though our app component is taken in the real service. And we can see here that if we run it in a real environment, we see this is real data. And if we also look here, we can see that we have a screenshot of this is mocked data display. Well, hopefully this gave you a little bit of insight into how Angular unit testing works, and yeah. And finally, thank you for your attention so far. It is now Q&A time.